Good morning all. My name is Thavinnesh RAJENDRAN. Today I will be presenting on my final year project 1, which is quality investigation of 3D printed ABS and PETG parts. This study conducted under supervision of Professor IR.TS Dr. Sivarao Subramanian. First thing first, to understand the title better, we must ask ourselves several questions. What is 3D printer? What is quality? What is ABS? And what is PETG? First, we look into 3D printer. 3D printer is an additive manufacturing process of creating a three-dimensional object from CAD model. Second, what is quality? Quality is described as a set of features chosen based on measurement, accuracy and precision. Quality is also rated in terms of absolute criteria that must exceed in order to receive a quality grade. You might wonder what is the link between quality and 3D printer. To ensure the satisfaction of the 3D printer user, the quality is important. Next, what is ABS? ABS, or known as acrylonitrile butadiene, is a polymer made by copolymerizing three monomers, which is acrylonitrile butadiene. ABS is tough, resilient, and easily modeled, which is suitable for 3D printer. Lastly, PETG. PETG is a polyethylene tetrapentylate glycol, or also known as PETG, is a thermoplastic polyester that's deliver chemical resistance, durability, and formability for 3D printer. There are several problems stated in this research. Among them, traditional methods of ensuring qualities do not effectively address global markets and customer needs. Second, 3D printing technology is rapidly growing in line with demand of recent industry development. Thus, the accuracy and physical appearance of the printed parts are becoming crucial as it reflects quality of its product. Next, 3D printing process as a complex mechanism in building a part and often poses difficulty in understanding how the material will determine part quality and accuracy. Lastly, there is no time gap between R&D stage and mass production stage. Moving on to the objective, the primary objective of this investigation are identify the quality and performance of 3D printed parts. Next, compare and evaluate the quality and performance of 3D printed of ABS and PETG parts. Lastly, validate the quality and performance of the most stable 3D printed parts. Well, for the scope of the study explains the extent to which the research area will be explored. In this case, the test specimens were prepared using Ender 3v2 FDM 3D printing technology. ABS and PETG are the used material for this purpose. Tensile tests and flexural tests of two plastics will be carried out to examine the mechanical properties. Furthermore, scanning electron microscopy (SEM) imaging will be utilized to analyze and compare fracture surface between specimens. To understand the literature review vividly, there are several ways to identify the quality of the 3D printed parts. Among them, there are aesthetical view and performance view. Aesthetical refers to the way a product looks and feels. The first impression of a product is often visualized, making aesthetic very important. A product must work well as have a good design features. Under the aesthetical view, they are divided into two. Firstly, surface finish. Secondly, dimensional accuracy. For surface finish, Barrios and Romero's stated that the printing of the parts with certain surface characteristics require a systematic and scientific study. For dimensional accuracy, Ansari stated that to meet the performance criteria in 3D printing, it requires the overall improvement in quality of printed parts, including dimensional stability. For performance view, product performance is described as the response of product to external action in its working environment. 3D printed objects' performance is determined by its intended use. It may not have all the essential features if it is simply a prototype, but its performance should be equivalent to that of a product made using traditional manufacturing procedures. Under the performance view, they are divided into two, tensile and flexural. For the tensile, Rabuchik stated that the tensile mechanical properties of a polymeric FDM parts are affected by the FDM design and processing condition, frequently displaying anisotropic mechanical property owing the selection of particular orientation of infill layer. For flexural, Mohammed stated that the large number of FDM parameters and high degree of interaction between the parameters affecting the flexural properties. Moving on to methodology, its specified procedure or technique used to identify, select, process, and analyze the information about the research. As you can see here, the entire workflow of the research are represented here, starting from selection of the 3D model and comparative analysis. The STL file will be generated after the proper selection of 3D model. Following the generation of ST model, ABS and PETG material will be selected. The selected material will be undergoing 3D printing process. The printed specimen will be undergoing mechanical test, which is tensile and flexural test. The observation will be held while and after the test. After succeeding the observation, it will be led to microstructural analysis and comparative analysis. Moving on to the sample preparation, the specimens are prepared according to tensile and flexural test specimen according to the standard. The material used are ABS and PETG as mentioned before. The specimen for flexural tests are according to ASTM D790. Well, for specimen for tensile tests are according to ASTM D638 Type 1. After preparing the test specimen, the specimen must undergo the mechanical test. The mechanical tests are conducted using Universal Tensile Machine (UTM), Shimadzu, Japan. The mechanical tests are divided into two, tensile test and flexural test. Tensile test is a destructive method in which specimens of a standard shape and dimension are prepared according to ASTM D638 Type 1. The specimen is subjected to an enzyme load. During the specimen test, a dog-shaped bone specimen is gripped at its two ends and is pulled to elongate at the determined rate of its breakpoint. Next, the flexural test. The flexural test method is measure the behavior of material in which specimens of a standard shape and dimension are prepared according to ASTM D790. The specimens are subjected to a simple bending loading with a 3-point bend fixture, which will be test the specimen of 3D printed part. The 3 points of bending flexural test provide the value of modulus of elasticity in bending, flexural stress, flexural strain, and flexural stress and strain response of the material. After succeeding the mechanical test, the specimen must undergo microstructure analysis. Before scanning the microstructure under SEM, the sample needs to coated first with process of sputter coating because it is necessary to obtain the good quality SEM image. The process of sputter coated are conducted using SE mini sputter coater. After applying the coating, the specimen will undergo the Carl Zeiss Evo 500 SEM machine to scan the microstructure. Based on the observation on mechanical test and microstructure scanning, the stable material will be validated. With that, I end my presentation. Thank you.